Hello everyone, we are group 7 and we have 5 members in our group, which is me, Tang Wei Hong, Tan Ti Liu, Wong Xiang An, Keng Shiyong and Teo Po Xiong. So in this mini project, we have listed 5 real-world problems that related to solid mechanics too, and we have chosen one from them as our group mini project topics. So the problem related to the strength energy is selected for our group mini project, and we will find the strength energy in bending and solve the problem by using the Castigliano's theorem. So first, what is strength energy? Strength energy is the form of potential energy, or it can be defined as the increase in energy associated with the deformation of the members. Besides, strength energy is equal to the work done by slowly increase the load that applied to the member. The energy or work done that applied to an elastic member is stored as strength energy, and it might be regained by relax the elastic member again. So to find the bending strength energy in beam, we are going to use the formula U equal to integration of m squared over 2 EI, which m is the moment applied to the beam, L is the length of beam, E is modulus of elasticity, and I is the area moment of inertia. So the moment of beam is needed before we start the calculation using this formula. So we are going to introduce the Castigliano theorem. Castigliano theorem is named after the Italian engineer Alberto Castigliano. This theorem uses strength energy to determine the diffraction of beam or elastic member that required repeated integration of singularity functions. It also allows us to determine the diffractions of objects that have variety cross-sectional areas. And the formula for it is delta over theta U over theta P, which delta is a diffraction, the U is the strength energy, and the P is torque of force of the object. And after we derive the formula, we will get the new formula as delta equal to m over EI times delta U over delta P, and then we integrate it. By using the method of sections, inertial moment and partial derivative is determined, and then finally we will get the diffraction of the beam. That's all for me, and I will pass the presentation for the next member.
Assalamualaikum and selamat sejahtera to the doctor. My name is Keng Shiyong. Now I want to continue to my part, that is the real world problems. Our group have 5 options. These are cantilever beams, solid steel shaft, pliers, there is the plier gabon, and 4th is the beams, and 5th is the strength analysis. Then we just go through. The first one is the cantilever beams. The most historic and popular cantilever construction is the Forth Bridge, which located at the east of the United Kingdom, Scotland. The bridge design is based on the cantilever theory. The designers are Sir John Philip and Sir Benjamin Baker, and both are the popular civil engineering at that time. The total length of this bridge is 2,467 meter, and its width is the 37 meter times the 9.8 meters. This long iron slack is start built at the 1882 and end the project at 1889 years. Total time spent for this bridge construction is 7 years. Then we go through the second one is the solid steel shaft. Shaft is the part of the machines that take power from the engine or motor to place where useful work can be done. Nowadays, shaft have been divided in many different uses. The most popular and widely used is drive shaft. It is used in vehicles mostly. Since the first car was created in 1672, the photo is like this. The shaft had been used in the model At that time, this vehicle is not using petroleum for combustion, where it's using the steam power. Although recently our technology is very advanced, the fuel vehicle are replaced by electrical vehicle gradually, such as the Tesla company and the NIO company. However, shaft still become the important component since 1672 years, even cannot be replaced by others. So we can know that the shaft is very important to our to the contribution of the vehicle. The third one is the pliers. There is the plier gabong. Many tools used nowadays always be improved whatever in designs, beauty, even other aspects. The most common hand tool in our life are the pliers. The pliers developed in Bronze Age Europe. Generally, pliers made out of a pair of metal first-class lever joined at the fulcrums, which located closer to one end of the lever, creating short jaw on one side of the fulcrums and longer handle on the other side. This design creates a mechanical advantage, make the force of the hand's grip to be amplified, even increase the force and focus on an object within precision. The mechanical advantage also create ergonomy designs. The ergonomy design is very important because it can prevent the carpal tunnel syndromes. What is the carpal tunnel syndrome? The photo is just like this, the hands. We can see the hand is abnormal with us. The fourth one is the beams. Wood beam mostly used in building or architect field. A beam is one of the structural elements that primarily resists load applied laterally to the beam axis. When discussed about the beams, issue that will be related is Tacoma Narrow Bridge. The bridge is a kind of bridge that, based on the analysis of bridge beams, even is a kind of suspension bridge. Tacoma Narrow Bridge is located at the U.S. Washington. This popular bridge opened to the traffic on July 1, years of 1940. The total length of this bridge is at 1810.2 meter. Although this bridge is designed by many engineers, but the amazing issue happened at November 7th, years of 1940. At that day, the bridge was collapsed accidentally. The cause of this collapsing happened is not sure yet. So there are many different hypotheses to explain the collapsing. The most popular hypothesis is the bridge was resonance with the same as the torsion natural vibration frequency, but the actual failure was due to the aeroelastic flutter. This is the photo of the Tacoma Narrow Bridge. Then this is the photo related to the collapsing happen. Then we go to the last one, that is the strength analysis. When studying strength analysis, the related topic always is the stress analysis. This is because the apply of load will make the stress occur. If the force or load supply is too heavy, the object will undergo deformation. So if work is done by strength energy will exist. The strength energy is defined as the increase in energy associated with the deformation of the member. Therefore, it is undeniable to say that strength energies will cause the bending toward the subject, such as the beam, cantilever, or so on. If the failure calculation of mechanical designs and solid mechanics will lead to the collapsing happen. So far, the strength energy is always linked to the bending. In China, have the bending bridge has opened to public, that is the Louis Bridge. This photo is about show the Louis Bridge construction and designs. The total length of this bridge is 100 meters and a vertical height of more than the 140 meters above the Shangxiangzhou Valley because the bridge is between these two valleys, spanning each 100-meter long divider. It made up of 3 wavy bridges, and part each deck is made of the glass, something only hardy visitors would dare step onto, because the bridge bottoms is made up of the transparent glasses. Okay, now I want to pass to my fellow friends. Thank you, Doctor.
Hello everyone, my name is Teo Po Xiong and my machine number is AD190226, and now I would like to present the methodology part. So for the problem 1 of our case study, we need to find the bending strain energy. So the strain energy in bending formula need to be applied. So for B subjected to a bending load, since bending stress is equal to my over I, so we apply the my over I into the formula of Ui equals to stress square over 2E dV. Then we can get m square y square over 2ei square dV. Then we're setting dV equals to dAtx. Then finally we can get the final bending strain energy formula of integral of 0 to L m square over 2ei dx. Then for an end loaded cantilever beam, since m equals to negative px, which is the force time distance, then the U is equal to integral of 0 to L p square x square over 2ei dx, since we replace the px into the m square, and then the final answer we can get this one, and then we can replace x equals to L. So for solutions step for problem 1, first we need to determine the moment and reactions at A from the free body diagram of the cantilever beam. Then we're using the method of section to determine the internal moment 1 and internal moment 2. Then we apply the formula of the strain energy to find the bending strain energy. Then we add up together the strain energy for the internal moment 1 and 2 together, and then we can find the total strain energy. So for the case study of the problem 2, we need to find the deflection and also the slope at B. So the Castiglione's theorem need to be applied. And this theorem is named by an Italian engineer, Alberto Castiglione. So for strain energy of any elastic structure subjected to 2 concentrated loads, this is the formula given. Then we differentiate with respect to the loads. Then for an elastic structure subjected to n loads, the deflection xj of the point of application of Pj, which is measured along the line of action of Pj, can be expressed as this: xj equals to du over Tpj, theta j equals to du over dmj, and phi j equals to du over Ttj. And then the application of Castiglione theorem is simplified by the differentiation with respect to a load Pj, which is performed before the integration or summation to obtain the strain energy U. So for the beam, the formula is given by this. Then the m square U equals to integral of m square over 2ei dx. Then we apply the xj equal to du over Tpj. We get integral of m over ei times dm over Tpj dx. And then for thrust, the formula is given by the U equals to sum of f square times L over 2ae. Then with the same thing, we apply the du over Tpj into the formula. Then we can get the sum of the force times L over ae times the dfi over Tpj. So for solution step of problem 2, first we also need to draw the free body diagram of cantilever beam and using the method of section to find the internal moment about point A. Then using the method of partial derivative to find the derivation for deflection dmtp and derivation for slope dmdm prime. Then we apply the formula of deflection to find the deflection at B. And then lastly, we apply the formula of slope to determine the slope at B. So that's all for my part. Thank you. I will pass it to our next presenter.
Alright, so good mornings to my teacher, my friends. My name is Tan Tilox, and today I would like to discuss the result and discussion of this project. So firstly, we need to know what is the problem of this project. So this problem is about the cantilever beam. So which fits at one end is very useful to be a cantilever bridge without any supporting bracing or columns. So in this study case, we need to investigate the bending strain energy exerted on the beam and the deflection and slope of the beam due to the distributed load at the end of the beam. Alright, so we know that from the diagram, the bridge is exerted by 1.5 kN over meters and the span length is 12 meters. Right, so from the calculation obtained, we know that the strain energy is 455.39 joules, which exerted on the cantilever beams. So what it means? So it means that there is 455.39 joules increase in energy associated with the elastic deformation of the member due to the bendings. So this strain energy is very important in the design of a cantilever bridge because this energy can be transformed into a mechanical energy. Then the mechanical energy can be used to restore the beam to its original shape elastically and orientations when the loading is not exerted on the beam. Okay, and the next one is we also need to know what is the deflection of the beam. So deflection is the vertical displacement from its original positions due to the forces applied on the body. Alright, so the deflection is caused by the internal loading such as the axial force and bending moment. So there is 1.251 meter displacement of the beam due to the distributed loading. So why this parameter is very important because when there is excessive deflection, it will cause a cracking of the beam. So for information, the deflection of the beam should not exceed 1/360 of the span length of the beam, which is 12 meters. So 1/360 of it is 0.0333 meters. Alright, since our deflection is 1.251 meters, is larger than the deflection requirements. So meaning that the deflection of the beams under the loading is not in the safe line, so the bridge will not be safe. So as we know that the amount of deflections depend on several factors. The first one is the amount and location of the load. And the second one is the span of the beam. The third one is size. The fourth one is shape. And the fifth one is the nature of the materials. And after that, we also need to know what is the slope of the beam. So the slope of the beam is 0.139 radian after calculation. So what is slope? So it's the angle between the horizontal and the deflection positions. So it can be seen that the angle is relatively large and proves that the bridge is not safe enough to withstand the applied loads. Alright, so how can we do to improve the bridge? So we can reduce the distributed loads to 30 Newton over meters. Alright, so and after calculations, we found that the deflection is only has 0.025 meters. So this is smaller than the deflection requirement, which is 0.033 meters, by using the smaller distributed load, which is 30 Newton over meters. Alright, so it can be concluded that the bridge is safe under deflection. And after that, the slope of the bridge is 0.00278 radians, which is much smaller, and the slope has, it can be concluded that the slope has negligible effects on the bridge and can be considered as safe. Alright, so this is all for my discussion. Thank you.
Hi everyone, my name is Wong Xiang An, and now I'm going to present the conclusion part of this group project. So in the end of this group project, we are able to learn what is strain energy and also what is the Castigliano theorem. Strain energy is a form of the potential energy or can be defined as the increase in energy associated with the deformation of the member. And Castigliano theorem let us use the strain energies at the location of the forces to determine the deflections. And the theorem also allows for the determining of the deflection for objects with changing cross-sectional areas. So below this is the formula for the Castigliano theorem. And after deriving the equation, we will get this equation at the bottom of the slide. And by using this equation, we can calculate the internal moment and also the partial derivative. By using this partial derivative and also the internal moment, we substitute into the equation and then we will get the deflection of the beam. So after calculation, we can get the strain energy is equal to 455.39 joule. That means that there are 455.39 joule of strain energy exerted on the cantilever beam. That means 455.39 joule increase in energy associated with the elastic deformation of the member due to the bending. And also for the displacement, we get the answer is 1.251 meter. That means there are 1.251 meter displacement of the beam due to the distribution loading. And for the slope of the beam, we get the answer is 0.139 radian. Overall, we think that the bridge is not safe enough. This is because the displacement, which is 1.251 meter, already exceed the deflection requirement, which is 0.0333 meter, and also the slope of the beam, which is 0.139 radian, is too big. So in conclusion, the bridge design is not safe enough after validated by our calculation, and in suggestion, we think that we need to reduce the distribution load and also the span of the beam. Thank you. That's all my presentation.